Hello folks, welcome to another lecture in the Spark series. So the main agenda of today's lecture is writing a word code program using Spark. So basically a word code program in Spark is metaphorically treated as writing a simple hello world program in Python. So if you are starting new with Sparks, and then a word code program will be a good start, good to go. So let me name my notebook as what count. So, so yeah, we will start the video by listing the requirements. So basically we need a text file. Obviously we need a text file. So the text file could be of any size, but if you are starting new and if you are trying for new for the first time, then a simple text file would be a good start. And the text file that I'm using is as shown. So it's a simple text file of a few sentences. So yeah, let's get into that program. As you are aware that we can use RDDs or data frames and data sets when working with Spark. And if you are unaware of these things, what are RDDs, data frames, and data sets, then you can check my playlist where I have uploaded about these APIs. So will be I suppose that we can write a word code program using these two APIs, keeping the dataset API apart. We can use RDDs and data frames to write word code program. So I will make this lecture into two parts, where in this part one I will use RDDs, and in part two I will use data frames to write word code program. So let's bound this lecture completely around using RDDs. So the major difference begins with how the text file was read. So traditionally, the RDDs read text file as list of string items, and if you are working with data frames, then it will read the text file as a table, of a few rows. Each row has each sentence. So let's completely bound ourselves using RDDs for this lecture. So let me go let me go through the steps that we need to follow in order to write our completely write our work on program. So basically start with loading our text file. So after that we read our text file, and then sorry and then use of flatMap, map, and reduce by key functions. So if you are using RDDs, then we will be undergoing use of flatMap, map, and reduce by key functions, and these are predefined functions. So we don't need to specify or define these again. So let's start by loading our text file. And if you are using Databricks account community edition, then you should be knowing where you can upload your data and how you upload your data. This is my text file, and let me copy my text file path. So file location as text file. So let me run that, and after loading our text file, let's read our text file and store it in as RDD1. So spark content dot text file, and we'll specify the file location. So if you are not aware of what are the attributes or what are the input parameters that text file function takes, you can use help function, and every Python user I suppose will be aware of what a help function will return. So let's use that help function on our text file. So text file, and it will return what does it takes. So you can read this documentation, and it says that it takes few parameters that name as string, directory to the input file data, we can say that as path to the file location, and m- mini partitions which is optional, and Unicode by default true, or you can, if you need, you can change that. So by using help function we can, we'll be knowing of these things, and let's jump to our main agenda. So after reading this text file, let's print the text file. So for printing we use collect function. So as I said that RDD stores text files as a list of strings, and each string is a row in a text file. So uh, the text file that I'm using is this, and the first sentence or first row says, this is the first row that we can see, you can upload data to a storing area without connecting to a computer resource, but you must select an active compute resource to preview and configure your table. And this is the first row, and that is the first string that we can see here after reading that text file. So after reading the text file is as read as a string of sentence. So we need to break that sentence into a single word, and store it in usual as list of strings with each string a single word. So for that we need a flatMap function, and so let's use that function flatMap. So rdd1 dot flatMap, uh, flatMap takes input as a function, and we need to specify a function for uh, for this word count program we use lambda function. Lambda which takes sentence, and will split sentence, and let's store that in RDD2 so that we can print that. So let's print our RDD2. Yeah, so after using flatMap function on RDD1, we'll get a list of words and list of strings, and each string is a single word from the text file. So after splitting that sentence into a single words, the next function that we'll be using is map function. So the use of map function is it assigns a value of 1, and we will be assigning a value of 1 using map function for each word irrespective of how many times the word is repeated. So let's do that. rdd2 dot map, and again map function takes a function uh, as an attribute. We use lambda function, each word, and will return each word as a key and value pair, and will assign a value of 1 to each word irrespective of how many times the word is repeated. And let's store that in RDD3 so that we can print our RDD. So let's print that RDD3 dot collect. So yeah, you can see that we can see that each word is assigned with the value of 1 as a key value pair and key as the word and value as 1. So after using this map function, we'll be using a reduce by key function. So the use of reduce by key function is that it groups similar words and adds the values, so the key values assigned to them. So after using that, so let's write our reduce by key function. So let's use our reduce by key function. So RDD3 dot reduce by key, and it takes function as an input, and we use lambda function of x comma y such that we need x plus y, and we'll store that in RDD4 so that we can print. So let's print our RDD4. So yeah, we can see that the similar words are being grouped and the value will be has been added, and we can see that preview is repeated 4 times, and table is repeated 4 times, and in is repeated 9 times in a text file. So this is how we write what one program using RDD. So let's combine all these functions in a simple and a single function. So if in a professional way we use, let's use a user defined function and write our program, and which takes a file path as an input, and takes file path, and let's create an RDD, and spark dot spark text file of loc dot flatMap of lambda, which takes a sentence and returns split version of the sentence, and on that we use map function so that we can assign values for each word, and on that we use reduce by key method, which takes lambda function x comma y and returns x plus y. Sorry, we haven't finished our function. So return RDD dot correct, and this is our function. So let's print our function. Print what count file path, equals to file location. So yeah, the function that we have defined for writing a word count program returns the same thing that we have got here, that as area 1 connecting 1 but 1 and table 4, but in a different style. It is more as area 1 connecting 1 but 1 and preview 4 table 4. So if you want this as sorted, then you can use sorted function, so you can return the sorted form of the word counts. So yeah, just ignore this 50. Advanced automatically CSV, and the output is in a sorted way. So yeah, this is how we use RDDs to read, and this flatMap and map and reduce by key functions to write our word count program. So yeah, before winding up this lecture, I have a challenge for you. See, I intentionally added an integer here in our text file. So during this reading text file and flatMap for splitting, this integer is also treated as a word or a string. So the challenge here is intentionally add an integer in your text file as well, and try to write a user-defined function to skip these integers so that the output only contains a strings with value of how many times that they are repeated. And also if you need much more challenging part, then define your own flat map functions, your own map functions, and your own reduce by key functions.